chemical bonding and molecular structure. So here first part, chemical bonding. So what is a chemical bonding? How chemical bonding is takes place? Okay. So such a concept are included in this chapter. So first I take about the chemical bonding. Okay, chemical bonding. Bonding. Here the term itself indicates what is a chemical bonding. Now chemical bonding means the bonding takes place between the different constituent particles. It may be atom, or it may be ions, or it may be molecule, is known as a chemical bonding. Suppose one example, sodium chloride, NaCl. The constituent particles of the sodium chloride is Na plus and Cl minus. These are the constituent particle. The constituent particle here, the constituent particles are here ions in case of sodium chloride. Suppose you take as example ice. The ice consists of a large number of water molecule. It consists of large number of water molecule. Therefore, the constituent particles of the ice is a solid, the constituent particles of the ice is molecule. Here the constituent particles is equal to which one here? Molecules. Constituent particle is a molecule. In case of ice, constituent particle is a molecule. In case of sodium chloride, constituent particle is ions. If you go for one more example, if you take a copper metal or a copper piece, copper metal, here what is a constituent particle? The constituent particle is atoms. Okay, because copper metal consists of large number of copper atom. That copper atom, it consists large number of copper atom. The copper atom hold together by some force of attraction. In copper metal, there is a large number of copper atoms is present. That copper atoms hold together by some attractive force. That attractive force is known as a chemical bonding. If you go for the ice, the constituent particle is H2, water. The H2O is hold together by the hydrogen bonding, O. Here hydrogen, here this is one water molecule. So take another water molecule, this is another molecules of water, O, H, second molecules of water. So large number of water molecules are present, here H, O, H. Now this water molecule hold together by the bonding. This is here hydrogen bonding takes place, or here hydrogen bonding takes place here. Means the attractive force, which is attractive force in hydrogen bonding. The attractive force which holds the constituent particles. If you go for the sodium chloride constituent particle is Na plus and Cl minus. Here large number of Na plus and Cl minus exist in the crystals of NaCl. This Na plus and Cl minus hold together by the some electrostatic force of attraction. Electrostatic force of attraction. Or ionic bond. Electrostatic force of attraction, its another term is ionic bond. Here Na plus and Cl minus hold together by the electrostatic force of attraction, that is called ionic bond exists between the Na plus and Cl. Actually ionic bond is known as attractive force. That attractive force holds the constituents of the NaCls. That attractive force is known as which one here? Chemical bonding. So in generally the chemical bonding means the attractive force which holds the different constituent particle together in different chemical species. Okay, here the constituent part, in case of sodium chloride, constituent particle is Na plus and Cl minus. These are hold together by the ionic bond. In case of ice, constituent particle is a molecule, means water molecule. They are hold together by the hydrogen bonding. In case of the copper metal, the constituent particle is atom. The copper metals are hold together by the metallic bond. Means attractive force which holds the different constituent particle in different chemical species is known as a chemical bonding. So that's why chemical bonding can defined as the attractive force which holds the various constituent particles here. Various constituent particles. So what are here constituent particles may be atom or ions or molecule together in different chemical species is known as a chemical bonding. This is a definition of the chemical bonding. Okay, but it's correct. Chemical bonding means attractive force that is exist between the different constituent particle in different chemical species. Okay, it's correct. Now, how attractive force exists between them? How it's possible? How attractive forces exist between them? But the chemical bonding totally it involves the union of two or more atoms. But the attractive force exists between the different atom by the rearrangement of electron in the outermost shell or a redistribution of electron in the outermost shell. For this purposes, I take one example, sodium chloride as a examples here. So in the case of sodium chloride, constituent particle is a Na plus and a Cl minus. Here Na plus and Cl minus hold together by the electrostatic force of attraction is known as a ionic bond. So how this how the attractive forces exist between? Because in case of sodium chloride, sodium, we know that sodium atomic number is 11. Its configuration is 1s2, 2s2, 2p6, 3s1. Next, chlorine atomic number is 17. The configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Here say sodium is correct. Sodium has one extra electron in the 3s cell, extra electron. If you lose this electron, it attains the stable electronic configuration, means noble gas configuration. Chlorine actually one electron is required to attain the stable electronic configuration. Therefore, sodium atom has high tendency to loses the one electron. They form Na plus ion. Cl minus chlorine high tendency to gain one electron. The electron donated by the sodium, that electron gained by the chlorine, they form Cl minus. See here, sodium loses the one electron means it attains the stable electron configuration. Or chlorine high tendency to gain the one electron means 3s to 3p6 configuration. Now Na plus and Cl minus afterwards, Na plus or Cl minus hold together by the electrostatic force of attraction or ionic bond. Okay, means the chemical bonding involves the union of a two or more different constituent particles, means or in general I take atom, or a chemical bond involves the union of the two or more atom by the redistribution of electron, by the either by transfer of the electron. Here redistribution of electron takes place, means the one electron is lost, here one electron is a gain. That's the redistribution of electron takes place in the outermost shell, either by losing the electron or by transferring the electron or by gaining the electron. Sometimes there is sharing of electron also takes place. For example, SCl molecule, it is the SCl is the example for the non-polar molecule. It actually hydrogen has one electron in the outermost shells, 1s1. Chlorine, I already write here, chlorine. How many electrons here totally? 5 plus 2. 5 plus 2. Here 7 electron is a present. I can represent dot here, 1 electron. Here 7 electron, 1, 2, 3, 4, 5, 6, 7 electron totally. 5 plus 2 7, 1 2 3 4 5 6 7 electron is present. This dot represents the electron. Now this electron and this electron sharing between the two atoms means the sharing is takes place, means hydrogen, this electron sharing here. So that means sharing means this electron, these two electron either belongs to hydrogen or it also belongs to chlorine. These two electrons share. Suppose these two electron belongs to chlorine means, so number of electron around the chlorine is 8. It's at an octet configuration or stable configuration. Hydrogen, if these two electron belongs to hydrogen means it is attained the stable 1s2 because maximum capacity of hydrogen only 2. Yes, stable. Correct, because it has only one shell, it's a 2 electron can be accommodated. Okay, means these two electrons sharing between the atom, as a result they attain stable electron configuration. Okay, means this is also redistribution of electron outermost shells. Okay, totally the chemical bonding, it involves the union of the two or more atom by the redistribution of electron in the outermost shell, either by transferring of the electron from the one atom to another atom or by sharing the electron between the atom. As a result, each atom attains the stable electronic configuration is known as the chemical bonding. So that's concept I write here. The chemical bonding involves the union of the two or more atoms through the redistribution of electron in the outermost shell by outermost shell involving electron transfer from one atom to another atom or sharing the electron so that all the atom acquires the stable electronic configuration. This is a way of formation of the chemical bonding. So this is about the formation of chemical bonding. How chemical bonding is takes place either by transferring of the electron or by the sharing the electron. As a result, chemical bonding is takes place between the different constituent particle in different chemical species. Okay, next about the Cousel-Lewis approaches of the chemical bonding. How chemical bonding is takes place? That is explained by the one of the theory is Cousel-Lewis concept of the chemical bonding. Actually, this concept explain the formation of the chemical bonding in terms of the electrons. With the help of the electron, they explain how chemical bonding takes place between the different atoms. According to this concept, atom is a positively charged kernel. One atoms, in general we consider sodium as an example. Sodium is known as a positively charged kernel. It is called a kernel. Here kernel includes nucleus and innermost electron plus and outermost electron. Here kernel means sodium atomic number we know that 11. Here kernel means sodium atomic number 11, configuration is 1s2, 2s2, 2p6, 3s1, 3s1. Here sodium has one electron in outermost shell. This is outermost electron, one electron in outermost shell. This is the inner shell. Actually this is a K shell, it's L shell, it's M shell. So this is the inner shells. So kernel includes nucleus plus innermost electron till here. It's called electron. It's called kernel. Kernel includes the nucleus plus innermost electron. Innermost electron means electron present in the K shell as well as L shell. And it should be containing a 8 electron in outermost shells. That 8 electron occupy the 8 corner of the cube. Then atom is stable. So, okay. So in general I give one more example I give it here. For example, sodium Na plus ion. Na plus ion configuration 1 electron less. So here configuration 1s2, 2s2, 2p6. It's a configuration of Na plus because 1 electron less. So here kernel means nucleus plus inner shell. Here this is inner shell, this is outer shell. Nucleus plus inner shell, and outermost electron must be containing 8 electron. That 8 electron accommodated in the 8 corner of the cube. Here suppose Na plus, here Na plus, it has 8 electron at 8 corner of the cube. This is a cube I consider here. So here cube. So this is a cube. So it's a cube. Suppose this is a sodium Na plus here. This is actually here kernel plus outermost electron must be 8. How many electrons are there? 6 plus 2. 8 electron is present here. 8 electron. 8 electron must be occupy the 8 corner of the cube. It's a condition. Now atom is a stable. Yes. Now Na plus is a stable. Why Na plus is a stable? Because outer shells containing 8 electron. That 8 electron occupy the 8 corner of the cube. That's why Na plus is a stable. Okay. So one more example for this one. Cl minus. Cl minus is a stable because Cl configuration 1s2, 2s2, this is 17 plus 1 18. Actually chlorine 17, you know that. 2p6, 3s2, 3p5. So I add one extra electron, it becomes 3p6. So this part, see, nucleus plus inner shells is called kernel, positive kernel, and outermost shell containing 8 electron. Yes, here 8 electron is present. This is a cube, simple cube. Here this is a chloride ion I consider. So here 8 electron is present at 8 corner of the cube. That's why this atom is stable. Okay, this is about the Lewis concept. Okay, according to this one, here atom considered to be made up a positive kernel consisting of nucleus and inner shell, and outer shell that could accommodate a maximum 8 electron. The 8 electron occupy the 8 corner of the cube, which is surrounded the kernels. Here this part, nucleus and innermost electron surrounded by the 8 electron. That 8 electron occupy the 8 corner of the cube, then atom is a stable. Here next question, whether sodium is a stable? No, sodium is not stable. Why sodium is not stable? Because it has only 1 electron outermost shell. Okay. Whether chlorine is a stable, Cl is a stable or not? No, it is not stable, because chlorine means 1s2, 2s2, 2p6, 3s2, 3p6, 3p5 chlorine configuration. 1s2, 2s2, 2p6, 3s2, 3p5, because here outermost shell contain only 7 electron, not 8 electron. That's the chlorine is not stable. Sodium atom is not stable, but sodium ion is a stable, or a chloride ion is a stable. It's a stable because they have 8 electron outermost shells. Okay. Similarly, calcium, atomic number 20, it is not stable. Suppose calcium loses the 2 electron, then it is a stable. Okay. So now means according to this postulates, atoms become stable when chemical bond takes place between the atoms. Now, for example, Na plus and Cl minus both are the stable, because sodium loses the 1 electron, as a result they form Na plus. Chlorine gain the 1 electron, they form Cl minus. Afterwards they are hold together by the ionic bond. As a result the molecules becomes stable. And according to this concept, Na plus contain 8 electron outermost shell, Cl minus also contain 8 electron. That's why they are becomes stable. According to this concept, atoms achieves more stable when bond formation takes place between the atom, then they achieve the more stability. So these are the important concept of the Lewis concept. Here there are 3 concepts I given. The last concept, Lewis proposed that atoms achieve the stable octet when they are linked by the chemical bonding. When a chemical bonding exists between the atoms, as a result they achieve the stable octet configurations. Okay, next concept is a causal concept of electrovalent bond, ionic bond. The formation of the ionic bond or covalent bond. Explanations was given by the causal. Actually, causal predict the separation of the elements in the periodic table. Actually, in the periodic tables, alkali metals, alkali earth metals, next P block elements, next D block elements. These are different groups of elements are there. But their characteristics, properties of the elements also different. Here alkali metals high tendency to lose the electron. Noble gas halogen high tendency to gain the electron. Here in the case of the electrovalent bond or ionic bond, there are two species are required. One species high tendency to lose the electron, another species high tendency to gain the electron. Then he can predict, causal predict the position of the elements in the periodic table by the first postulates. In the periodic table, highly electropositive elements and highly electronegativity elements are separated by the noble gases. The noble gas separates the high positive elements and highly negative elements. For example, neon is noble gases elements. Noble gas separates the, means neon is separates the high electropositive elements and high negative elements. Because of sodium, it's a high electronegative elements. After sodium, here we get here sodium. Next, I go for the, or in general, I can take hydrogen here helium. Next, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Next, again, sodium, magnesium in the periodic table. Okay, go for aluminium, silicon, sulfur, phosphorus. Okay, here phosphorus, sulfur, chlorine, argon. Okay, so next potassium, calcium. Next go for here 13 groups. Next scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Here actually the alkali metals and noble gas separated by the noble by the halogen separated by the noble gas. Neons separates the lithium or beryllium alkali metals and noble gas like next elements sodium or chlorine and sodium are separated by the neon. Argon separates the chlorine and potassium. Potassium and chlorine separated by the argon. Neon separates the sodium and chlorines. So this is the first postulate. In the periodic table, highly electropositive alkali metals and electronegativity elements are separated by the noble gases. Next, alkali metals, we know that high tendency to lose the electron, they forms a cation. Next, halogen high tendency to form, so halogen positive by gaining the electron. Halogen forms a negative ions here, not positive ion. Halogen forms a negative ion by gaining the electron. Alkali metals forms a positive ions by losing the electron. Now negative and positive ions both are stable by attaining the stable electronic configuration, and positive and negative ions are stabilized by the electrostatic force of attraction. Simple example I take as example here sodium. Sodium atomic number 11, its configuration is 1s2, 2s2, 2p6, 3s1. Sodium high tendency to loses the one electron, they form Na plus, and it is attain a stable electronic configuration after formation of cation. Chlorine atomic number is a 17, configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Now chlorine high tendency to gain one electron, they form Cl minus. So it attained Cl minus attained stable electron configuration after gaining the one electrons. Means it becomes 3s2, 3p6. Okay. Now Na plus and Cl minus hold together by electrostatic force of attraction. That electrostatic force of attraction is called ionic bond or electrovalent bond, or resulting compound is called electrovalent bond or ionic bond. So totally a bond formed by the as a result of electrostatic attraction between the positive and negative ions was termed as a electrovalent bond. Two opposite charged ions hold together by the electrostatic force of attraction, resulting compound is called ionic bond or covalent bond. This is about the formation of the ionic bond or covalent bonds.